All right, we're going to continue our look at ellipses. So we're going to focus a little bit more on it. So we have an horizontal one, which pulls in the x-axis. We have vertical that pulls in the y-axis. Your vertices are located on your major axis. Your major axis is the direction, that the longer one. Your minor axis is the shorter one. And so when you have a vertical one, those are intertwined because your longer axis is vertical. So that's your major. And then your shorter axis is horizontal. So that's your minor. So you need to pay attention to that. Your vertices are on the major axis where the circle touches a major axis. So they are A units away from the center. So the center to one of your vertices is A. All right. So on the vertical one, it's going up and down. So from the center to the circle, that's A. So it flips over depending on what kind of ellipse you have. All right, so let's take a look at covertices. Covertices are on the minor axis, and that's the distance from the center to the circle. All right, so I'm just going to label your vertices on your major axis and your covertices on your minor. And that distance is B. That distance is B units away from the center. So from the center to the co is B. All right, so from the center to the co is B. So the shorter side is B, the longer side is A from the center. Okay, we're looking at the length of the major axis. So here's the major axis. The length is, there are two A's, so that's going to be A plus A, that's 2A. And your minor is B plus the other B, which is 2B. All right, the foci is C away from the center. So and your foci is also located on your major axis. So from the center to the foci, that's C of your major axis. So whether that's vertical or horizontal, whatever your longer side is to the foci is C. All right, so let's go ahead and circle vertices, foci, and right center, because all three of those are on the major axis. So go ahead and write down. All of that is on the major axis. There is a formula to find C. C is the square root of A squared minus B squared. So not to be confused with Pythagorean theorem. A squared minus B squared, the square root. All right, this is how you have an ellipse in standard form. Remember, it's just like a circle. You have x minus h squared plus y minus k squared. And instead of your radius, you have 1, and then you have a fraction. You have a squared, which is always your longest side, and b squared, which is your shortest side. So this one is the horizontal standard form. So obviously vertical, you're going to switch a squared and b squared. So again, the longest side is with the variable it belongs to. All right, let's take a look at some examples. So you can see the longer side is underneath the x variable. So this is stretched in the x direction. The shorter side is your y variable. So that's your co-vertices. All right, so let's go ahead and do this. So it's the center. So this, you know this from before, -1, +2. Where are your vertices? Okay, so my vertices are where A is the distance away from A. So square root of 49 is 7. Where's my co-vertices? Square root of B, which is 9, which is equal to 3. Use the formula. C squared is equal to 49 minus 9, which gives you 40. Take the square root of that, square root of 40. That's going to be my foci, all on my major horizontal axis. So it's around 6.324. All right, so let's go ahead and actually graph that in, right? So again, we're going to start off with the center. So find your x and y axis. So I put a plus there so you can see. I'm going to use a pen just so it's clearer. So -1, 2, that's my center. Then count 7 boxes, and this is horizontal. So I'm going to count horizontally 7 boxes, put a dot on each side, because that's my A distance. And then my B is going to be 3 dots on each side. All right. My co-vertices is roughly 6.3, so maybe about here on each side. And again, remember that's on your major. Then go ahead and just draw your ellipse as as well as you can. That's it. That's how you draw your ellipse. So I'm going to start you off on the second question, and then you're going to complete it yourself. All right, so we're going to complete the square with a 3-step process because we first have to get it into standard form. Okay, so let's start off with the x squared. We're going to need to factor out that 4, leaving x squared minus 8x, because -32 divided by 4 is -8. Leave a space. Then we'll factor out the y. There's nothing to factor out, so that's going to be y squared plus 8y. Leave a space. Take the 76 to the side. It's going to be -76. All right, go ahead and write my other line. Leave a space. 4x squared plus y squared equals. All right, now my 3-step process. Okay, step 1, divide by 2. -4. Step 2, square, +16. Step 3, multiply and apply to the other side. So 4 times 16 is +64. I'm going to do the same thing again. Divide by 2, square it, multiply, and there's an invisible 1 outside, apply to the other side. Okay, 3-step process. Combining all of that, you're going to get 4. All right, now that's what you knew before, but remember, a standard equation has to have it equal to 1, right? So it has to equal 1, so I have to divide everything by 4, so it's equal to 1. So divide by 4, divide by 4, divide by 4, and that's going to give me my 1. So that crosses out. leaving x minus 4 squared plus y plus 4 squared over 4 equals 1. And now it's in standard form with a being over the y, so that's my longest side, so it is a vertical ellipse. So go ahead and complete the question and then graph it.